See my patience, I just came here to defend.
So we're here from Nomoko. We're a startup, a company from Zurich in Switzerland. I'll keep everything in English, although we have a very good or French native speaker here. So if any questions are on French, so please refer to him. I understand most of it, but I'm very, very rusty, so we'll keep it in English. Also for the purpose because the company, the internal language actually is English, so we communicate everything in English. We have 14 people right now and 12 nationalities, so language has to be as unified as possible, so that's why we keep it to English. I will give first a short presentation, or actually a long presentation, what the company is about. That is mainly the pitch deck we also use to present to investors, so you also get a little bit of feeling what it is to present to an investor, what is documentation you need, and so on. And afterwards, I'll continue with a short presentation, what it is to actually found a company, what it is, what are the most questions you always get, and it's an assembly of questions I received a lot from other founders which are just in the process, from people that want to start a company, and I collected them and will give you just very short answers, and the goal is to push you basically through this first couple of months where these questions will bug your head and they will go around, and you can kind of skip these first 6 months. Yeah. I gave the same presentation also at ETH, the technical school in, or the very good famous technical school in Zurich, and they really liked it, so that's why I said, like, okay, if you have enough time, I will give you the same talk. Okay, this is bullshit. So quick, yeah, we have to include it. It's legal stuff. Quick overview: what is happening for the pitch? Not very important. We start first with the vision. So the vision we have as a company is we want to map the entire world as a 3D model, basically. So we want to have a recreation of the world we live in as a 3D model, and we don't want to have it as ugly and undetailed as some other companies have it, but very, very detailed. So that means that every millimeter in reality is basically one point in our 3D cloud that we record of the whole world. Of course, a very ambitious goal, but there are very many small steps to actually get there. Yeah. The reason why we do it is that we believe that a lot of applications which happen in the future are very driven on 3D content. So they somehow need to understand what the 3D of the world surrounding them looks like, be it for self-driving cars which want to navigate in a city, or be it robots, or be it computer games that want to easily be basically played in a virtual city or in a virtual environment, or which want to be created easily. Yeah. Virtual reality, of course, augmented reality, all these things in the end, they need 3D content. Yeah. The more detailed it is, the better is the experience, the more real it feels, and the more satisfied everyone is. Yeah. Now, it was, I think, half a year ago, we talked to the Chief Innovation Officer of Ubisoft. I think you all know the company, unless some investors. And they rebuilt the Cathedral of Notre Dame. It took them, with 5 people, it took them 14 months to rebuild it, because it was a process done manually. Yeah, so they found no technology which actually would deliver them a 3D model accurate enough that they could use it for the last Assassin's Creed version. So they just rebuilt it by hand. Stupid approach, in my opinion. And we asked her like 5 times, so why did you do it this way? It's like, we have no other solution right now. Yeah. Is it the permission that you cannot record the cathedral? No. Is it anything else? Like, no. It's simply the fact there is no technology out there allowing us to reconstruct in a way that is simple and at the same time very accurate. So most 3D reconstruction tools you have these days, even if they reconstruct automatically, they have so much noise that you have to basically post-process the data really extensively, and only then you can really use it for a game. And that was for us a big insight, because it basically led us to that conclusion of what would be needed these days to really disrupt this industry. Because there's so many players which do normal 3D reconstruction, which use drones with normal cameras on them, and so on. So you somehow have to be different to those people, right? Otherwise, if you're just doing the same thing, then yeah, it's not so interesting. So to summarize, we need an easy, fast, and cost-effective way. Otherwise, I mean, if it's super expensive and if it's super slow, no one will actually care about. So you need to have in the technology, and I think this is a big difference between academia and businesses, that you need something which in real world is applicable and is feasible to earn money with. Yeah. So this is really important from a financial or from an economic point of view, which for the technological side, of course, sucks, because that means that it's much more challenging. Yeah. Especially for us, the fast part. Yeah. This one here, this is a bitch, but c'est la vie. And then it needs to be a technology. It doesn't need to be something which you can outsource to a cheap labor place and then just people do it by hand. And because you outsource it, you're faster and you're cheaper than the competition. That's also not, I think, the way you solve a problem feasible for the future. Yeah, like maybe for the first very proof of concept it might work, but it's not something sustainable. And then in the end, we want to create what we say lifelike 3D. And this is our definition, because so far we didn't find a definition that was actually putting everything in place that we need. So what is this lifelike 3D? That's 3D content which is so realistic that from the human eye you cannot really distinguish it from reality. So it's basically as real as possible. That's our verdict. Now the interesting part is, and especially if you look at virtual reality, is that number down there. So we as human beings, we see the world around us at 575 megapixel resolution. That's extremely detailed. I mean, if you compare that to cameras that we have, for instance, a GoPro or an iPhone, they have 12, maybe 20 megapixels. That's like a lot less than what is there. Yeah, that's 20 times less. And this is really important to realize also when most of you probably already have tried an Oculus Rift and so on. And part of why that experience is not so great or not as cool as you might hope is really in that part that our visual system or our eyes are really, really, really good. Yeah. So if you want to achieve this lifelike 3D, you somehow have to beat this benchmark. Yeah. Then you kind of are in this sphere. Now I already said, so this is I think really important for any company, but also when you develop new technology, that you always look around what is around you. Yeah, what are other people doing? What are the technologies which are already there? It makes absolutely no sense to re-engineer or just do something new because you think you're more awesome than everybody else. Sorry, I have to put the microphone a little bit more up. So just because you think you're awesome and because you like to develop a new technology doesn't necessarily make any sense. Yeah, so you always have to check what is the competition doing, what are other people doing, what is academics doing, that if we see there's another technology popping up which is solving this problem, then we basically incorporate that technology as fast as possible. This has always been our approach, and this will always be our approach. The moment you lose this, you basically get vulnerable that some new startup, some new company, someone else can basically take the innovation away from you because they work on something else. And this is also the reason why a lot of big companies in the end fail to innovate, because they have so much knowledge built up in a particular field that they stop looking somewhere else, because for them it would mean to completely forget what the resources they built, and then they basically also start at zero. And that's normally what you don't want to do, because your company wants to have an edge over the competition, right? So never ever forget to look around what the other people are doing. That's really, really important. So this is a little bit of comparison. We defined some factors here. So the level of detail, which is basically the lifelike 3D, the versatility. So it needs to be a technology which is applicable in all different situations. So it needs to be applicable in sunlight. It needs to be applicable in dawn. It needs to be applicable when objects move fast. So it needs to be something which is easy to handle. Yeah, it doesn't need to be something like a laser scanner you can put at night in a factory building and then you can record everything because nothing is moving. Yeah, or because you don't have much ambient light, which is which is creating noise for the signal. You don't want that. That's inconvenient. So versatility really is basically convenience. So these are the current methods used. Structured light, you project a light pattern. So for instance, like a pattern of stripes onto an object, and then these stripes, they are basically deformed based on the distance and on the shape of the object. And from that deformation, you calculate back the geometrical surface of that object. Very accurate, very precise, but only feasible to a distance of approximately, so if this is the object, you need to be like half a meter close to the object, otherwise it doesn't work anymore. So a cool technology, works really well, but scanning the Cathedral of Notre Dame, tricky. Yeah? Scanning a whole city with that, close to impossible. And then you have structured light, you have time of flight, which is, for instance, Google Tango is using that. So that's everything where you have an infrared or some sort of light source sent out, it reflects on the object and then it bounces back. Yeah? And from that time difference, you can infer where the object was. Problem there is, doesn't work so well if you have a lot of ambient light, and the chips to do it, they normally are very expensive and the resolution is not very high. So it's fast, it's good for robotics, but it's not really good for if you want to record something in very high detail. Yeah? And then of course you have the photogrammetry, which is basically using cameras, and then from different viewpoints you calculate the geometrical function, and from that you infer the 3D. But to that a little bit more later. So that's the requirements. Now the ticker doesn't work. So how did we solve this problem, or what is our solution to this? Yeah. And basically we developed a camera which is so high resolution with 800 megapixels and small and light at the same time that we can beat the competition by a factor of 10, even if you look at the really expensive, really good equipment which is right now on the market. So the first prototype we had in 2014 had 250 megapixels, was a huge thing. We called it the Beast. It was quite expensive and very heavy, but it was a proof of concept. And we built it in roughly 9 months after I had the concept in mind for over a year. We sat together with our second co-founder, our CTO now, and we built it in 9 months. And then we had the proof of concept that what we are doing is actually working. Now, the prototype we're working on right now has, or will have, around 800, maybe even 900 megapixels in resolution, and will be finished between summer, beginning summer, end of summer, something around that. And it will already be compact enough and light enough that you can actually put it on the drone. Now, in general, if you have any questions, because we have quite a small room and an easy audience, just ask and wave. Yeah.
So the first prototype is like he has more megapixels than the human eye.
Yeah.
What's the point?
So the point is that when you have, so for instance, the images that you also see on your smartphone, one of the reasons why they look so good, they're over-resoluted. So the moment you have more resolution, you can always downsample the image, and with that you can reduce noise. And noise is, for instance, or is something for 3D reconstruction which is very, very bad. So the more noisy the signal is, the more difficult it gets to determine what is actually a signal, what is really like properly a signal coming from reality, or what is simply noise. Yeah, so this is really important. And of course, and the other importance is if you have more than the human eye, you can be actually further away from an object, and you can still see like what Isaac, who is down there, you can still see all the details as if, as a human, I would be standing here. Yeah. So you gain this advantage that you can be further away from the objects and still get the resolution as if the human being would be standing much closer to the object. Because also what you have to realize for 3D, and Sebastian is going to talk about this as well, is in the end it matters how much resolution or how much density, we call it pixel density, you have on an object. So if you take an image of any object, be it a face, be it a computer or anything, what really matters is how much pixels do you record per square centimeter. And of course, if you're a kilometer away, you will not record as much detail as if you're just half a meter or a meter to that. So this is always the critical part. In the end, you always have the parameters, the distance to the object, the optics you use, and so on, which in the end will boil down to the amount of pixels you record per square centimeter. So, coming back to your question, the more you have, the further you can be apart, and the larger is the area you can actually record. Yeah? Clear?
You don't reference it, but I just checked again. The DARPA made...
Yeah, I know.
Nearly 2 megapixel
Yeah.
camera.
Yeah, I talked with the team, it was 2 years ago. I talked with the key engineers with them. They did a very specific camera for drones, but the thing is, yeah, like diameter is close to the screen thing, and they have a very specific setup which is very particular for their use. So this is official, so I don't know how much I should actually say about this, but we can talk afterwards what the purpose of this camera was, or it still is. Yeah, but these are the only ones which are going in this direction. And from their setup, how they construct the camera, it's not possible to make it smaller. And it's also not their interest. Yeah.
Yes, with so many pixels
Yeah.
in such a small device,
Yeah.
how much light do you need to take a picture?
Normal light.
Normal light.
Yeah.
So
Very normal.
dark situation
Yeah.
is
No problem.
no problem.
And yeah, we're actually now testing, or hopefully we'll get hands on a technology which is developed by a company in California. So we'll meet them in 3 or 4 weeks, where we can go even in very low light situations and still get very, very good images. But that's still to be shown. Yeah?
How do you plan to manage the size of the data?
Good question. We have one guy just working on this to kind of be proactive on that question or on that problem. And on the other hand, we simply bet on Moore's law. So that in the end, the computational time, data storage, and all these factors will continue to really step up their game. So we think that in 3 to 5 years, from the developments we see, also from Intel and so on, it will not be a big problem anymore. Yeah.
Just to keep on this one, if you had a rough estimate, a
Mhm.
scan of this room, would it be the gigabytes, terabytes?
For this room, it's difficult. I mean, I know for a city like Zurich, which is roughly, it's 20% less than the inner surface of Paris until the street around. How is it called? Yeah, exactly. Thanks. So that is around 7.5 petabytes. So that's 7,500 terabytes. And now to give you a perspective, yeah, a server containing that much information these days is around 500,000 to 600,000-700,000. So that's possible. I mean, it's something 10 years ago would have been impossible to be paid. Yeah? And right now, it's already last year when we checked, it was still at 1.2 million, and now it's already at 600,000. So this is how fast this stuff drops, basically. Yeah.
So much detail to access to the result.
Mhm.
We need big graphic.
Maybe. So there are several solutions. We're actually talking with a company which is now labeled themselves as a startup, but they're already 8 years around. But right now it's really hot to be a startup, so it helps them. And they developed a technology that they can display very detailed graphics on not very good computers like tablets, like iPhones, like Oculus Rifts, and so on. And they can run like The Witcher and all they did basically for them the downsampling, and they have a special architecture that they can run these kind of games at 120 to 360 frames a second. So also that displaying this kind of information is not our task to solve. So there's other people working on this, but we're also talking to NVIDIA to maybe get them as sponsors on, because they maybe would be really happy if we as a company succeed. Then more people need a new graphic card, and so you see, this is always how you can make very, very good connections. Yeah. Any other questions right now? Yeah.
What would be the possibilities of using such a camera on a satellite?
Yeah. So we talked to Planet Labs, which is a startup from San Francisco. It was 1.5 years ago. They simply didn't believe that we can do it. And they have a little bit of a different, I mean, for us, it's not really an interesting market because you will see afterwards, like we're not that much interested in selling a device. And if we sell a device, then we will sell a consumer device with high quantities. And satellites are simply no high quantities. It's 100 to 150 units you maybe potentially can sell. And this is more something, we're also talking to ESA for other purposes, the European Space Agency. This is more something we would have someone that makes a licensing and says, yeah, I want to adjust the technology for space, because you have cold temperatures, you have vibrations which are crazy in the launch, and there is all kind of nasty, messy stuff that you have to consider from a technological point of view. So yes, it would be possible, but it's not our focus at the moment.
Yeah, my question was, what would be the possible usage of such images? Does it make sense to have this image at this resolution taken by satellite for agricultural purposes?
Yeah, yeah. No, it doesn't, because we're actually running this case through ourselves, that we use drones instead of satellites, which is way cheaper. Because start of a satellite or a fleet of satellites, every rocket start is 140 million. So it's a little bit pricey, and you can get much further if you actually do the same as satellites do with high-flying drones or low-flying drones, depends on the case. But that's something we're actually looking into ourselves, because I think we can beat the competition there by a very, very large factor. Yeah, but very relevant for the application part. Yeah. Yes. Yes, of course. Of course, yeah. I will just hand this. Oh shit. I will just hand this off afterwards to Sebastian and Isaac, because Isaac is talking about the calibration, which is going exactly in this direction. So the optics, of course, you need to calibrate them. You need all tons of sort of stuff you have to solve and figure out. Yeah. So yeah, so you of course you need always different perspectives. Yeah, so if you want to take a 3D image of something, you cannot just take it from one side, because in the end you also want to have the 3D model, right? So you also want to see what is actually the scene looking from the back, right? You don't want to just see the front. I mean, otherwise it's kind of pointless if you have a 3D model and you only see this, what you can see right now, and you don't see the back. You cannot rotate it, you cannot really use it, so you always need different perspectives. Yeah. 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 Yeah, exactly. But of course, if you have, I mean, multiple drones, it's much more interesting because you're much faster. Yeah. And you don't want to have, I mean, I'll talk about this later about the city mapping. So when we record entire cities, you want to do this fast. You don't want to wait for it like for half a year. Yeah, you don't want to have just one drone going there for half a year and recording, because then you have different light conditions, you have different weather conditions, things change in this time frame. So that's not something you want. So you want something which goes fast, which goes in maybe 2, 3, 4 days. Yeah.
So you want to scan the whole world all at once?
No. Well, ideally, yes, but we just calculated to give you like a kind of insight. We would use, or we would need 10,000 drones to do it in 50 days, which is fast. Yeah. No. But yeah. Which is completely insane. I mean, it's like, you know, and then you cover areas which, I mean, you know, there is vast lands in Russia or in Alaska which you don't have to cover, but then you cover really like every bloody single meter, basically. Good. More questions? Yes.
How do you get the position of the drone?
Good question. GPS right now. So this is actually something why we want to collaborate with ESA as well, because at a later point we can use our own 3D model as a reference and our own images, but in the beginning you need an external reference system, and right now this is still GPS or different systems from, for instance, ESA. Yeah, for the drones right now, yes, but of course you can also reconstruct indoors, where there you can do the positioning of the camera with other methods. So you have, for instance, markers you can use, but you can also use from the features that you can detect, you can also infer on the position that the camera has within the room. So indoors is a little bit a more constrained problem. Yeah, and there you don't have a reference system, so that's why outdoors you need a reference system like GPS, because you want to reference it to other information systems. Yeah, for instance, where is the traffic system? So where are tubes basically? Where is the electricity system? Where is our water pipes and so on? So this is why outside you want to have it referenced with a GPS, but indoors you don't need it. Yeah. Yes. Yes. This is all the nasty questions. This is a very lovely audience. I love it. Yes, legal question. So right now, it still is the case that you can take images from public spaces, but you have to anonymize them. So you cannot have people on there if you want to sell it commercially. But said that, in 3D, if you have 3D shapes, recognizing humans as a shape is a little bit easier than on images. And so we plan to anonymize the data, but we're also trying the other way that basically Google did it. So we're trying to work together with the cities, with the politicians, with the municipalities, because they have a huge benefit from the data we actually can deliver to them. So we're somehow trying to work with them together. We have, so with the canton, so that's the bigger region of Zurich than the city, and they're super hyper what we do. And they actually asked us, so you know, we have a drone lying around, so you could have it, you can use it. And I was a bit surprised by that, because I was more expecting that legal challenge from their side, and more kind of a reluctant position. But we're working on this. We actually have some legal documents also on the self-driving car issue, because this is a huge topic. And the difficult part about it is that it's not defined, neither for the drones nor for that kind of data. So we're a little bit in a void there, which we know.
What about time? Everything is evolving continuously, so we'll have to remap every time.
So for just to give you an idea what time frame we are talking about. So if we have 100 drones, which is not that much, and they're purely flying, so there's no ground drones, we can recapture a city like Zurich in 0.02 hours. Yeah. So that's really fast.
How much time to get all this data to a server?
Different question. We don't know yet. I mean, this is again why we're also talking to ESA, that we can actually get all the data out of the drones through a satellite communication, because right now you need, especially if they're self-flying, so you want to have them flying autonomously and not by humans basically, so then you need data redundancy. So you need to have at least a 4G connection, you need to at least have a GPS connection, you need to have at least an onboard computer that can navigate on its own based on the last GPS point if all systems fail, and so on. So there's tons of securities that you basically have to comply to, and one of them is also satellite communication, which would be one way of getting the data out. Yeah.
And also, all this data,
Yeah.
will you make it open source or not?
That depends. That is a very, very, very difficult question, because that depends on a lot of things, because you also run into some sort of security issues. So you don't want to have all the people access to these kind of data. Yeah. So
But every city is open source.
yes, exactly. So this is a question for the future, which right now we cannot answer. I mean, it's something. There is so many good arguments for both sides that I think in the end the most pragmatic solution or the most realistic solution will be that we have, for some regions it will be open source, dependent on the state, basically on the government, and in some regions it will be closed source as it does ESA, so you can request to get access, and then it's open source. You don't have to
reconstruction of
Mhm.
Zurich, for example. How much time did it take to process data once you had it?
We don't know yet.
You still haven't done it?
No, we're planning everything for the reconstruction of Zurich, because we're still waiting to get the next prototype. With that, we can do everything. And so right now, we're planning everything because it's a really, really complex problem how you actually make the flight planning. How do you record efficiently? You have a flight time of a drone, if it's a fixed wing, of approximately an hour. So after an hour, it has to land again. So how to make all that system run efficiently, because you have to exchange the batteries, you have to get the data out, and on how do you actually manage this is insanely complex. Yeah, I mean, if it's just one drone, it's still okay, but if you want to coordinate 100 drones and they should all fly autonomously, it's fucked up.
For the reconstruction that you did
Mhm.
make, how much time did it take once you had the data?
Isaac. I mean, we worked with sample data, but he worked way more on this. So yeah, he will get back to that.
Should I get back to it?
Yeah.
Okay.
I know. I mean, this is an important question. I mean, this is also why we have one guy just working on this, because in the end, you can parallelize certain things. You can adjust the algorithms to certain parameters you put in before. So also the lens calibration, what you were already talking about, so the optics. But yeah, I mean, this is their presentation, so I don't want to take that away from them. Yeah.
What the type of lens using?
Again.
At the end of the process, what is the format?
The format. So we're very much in favor of just having point clouds. That from there we can then export to different formats. So we're looking actually to have a as universal format as possible, because we don't want to be stuck with one. And that's also something that has to be defined in the future. So right now we're working with point clouds, but of course it has certain advantages, certain disadvantages. And we're not yet at the point that we're actually looking, so this will be one of the future challenges on how do we get from having the raw data or the point clouds, how to get to the different formats which are needed by the industry. Yeah, because for the gaming you need different data than you need for cities. And everyone has its own kind of preference. So yeah.
Do you use colors?
So the last prototype was black and white, but so for us, we're always calculating from the data perspective. So with that much given data, what is the smartest approach? Is it to record with color for the 3D, or is it record in black and white and have for that more bitmap? So that's always kind of the trade-off, or we can store more information, but yet to be decided. There will be color, of course, because you need it for visual, kind of for beauty. So if you want to sell the data to a gaming industry, you need to have color. Yeah, but we don't know right now how much the color is adding to the reconstruction. But of course, it's also one element to differentiate between two objects. Yeah, so that's why color is in the end a must. And if you talk about agricultural applications, then you want to have even spectral information. So you want to have very narrow color bands. Yeah, so that's then even an additional information that we could integrate. So color is a huge topic on its own, coming from the debayering, but also what kind of colors do you actually use? Insanely complex in itself. I mean, we could talk 2 hours only about that, or even more. Okay, so yeah, this is getting a Q&A session.
About the reconstruction process,
Mm-hmm.
do you do it, obviously you will do it locally.
Yeah.
You're going to transfer such a huge amount of data somewhere remotely to make the calculation. So this means you will have some infrastructure going around and taking pictures and doing the whole stuff, then maybe sending, I don't know why, what format to some place where it's all...
So when you mean what I just understood with locally, so this is either on some Amazon cloud servers or on our own servers. If you mean that with locally, or do you mean it on the device itself?
No, on the area. For example, if
Yeah, yeah.
talking about Zurich, so we're in a team in Zurich.
Yeah,
to manage
yeah,
all of this
yeah, absolutely.
data
Yeah, yeah,
byte of
yeah,
break,
yeah.
because obviously
Yeah, no, absolutely. I mean, done locally, but it's done not on the drones itself. Like it's not done on the device. I mean that not. But there will be some analyses done because you have to analyze the data you get in. That you analyze on the fly if it's good data or not. That you can recapture certain areas where you had bad data. That yes, that you have to do somewhat fast or real time. But the final reconstruction will be done in a separate unit. There we're also talking to the big data centers like Swisscom and so on, so the mobile carriers, Post, Luxembourg, so these are, because the co-founders are from Luxembourg, they have huge data centers and they're also really interested in this stuff. Yeah.
You tell us picture size for Zurich.
Yeah.
Do you have an idea what will be the size of the 3D map?
So for us, yeah, I mean, this is the raw images. So this is all the raw image data we take in. What in the end, it depends on the format, depends on so many things. What the final result will be, I cannot answer at the moment. Yeah. It's simply, I mean, we were basically looking, is the raw image that the image data that we take, is that a limiting factor? Because if this would be a limiting factor, then we could also basically start with a different application. So this first needs to be feasible, and then we can basically move on. Okay, so now I will postpone the question. Okay, last question.
About the reconstruction, the model you get out of the data once you reconstruct is supposed to be as precise as the way you get the data?
So if I understood it right, so we want to get as precise as possible, yes.
But for real-time rendering, like...
Real time, no.
100 megapixels. Like
Yeah, no real time. Forget real time for the moment. I mean, maybe in 15 years, yes, but right now, the real time out of the picture. Yeah, impossible.
Or you can use that whole data set.
Yeah. Or you have to kind of, I mean, even just transferring the data to a data center that would compute it real time would already make it not real time because the data transfer is just too slow. So that's real time will be really, really interesting, but that's hopefully in 10, 15 years. My motion is okay. I mean, motion you can also... no oceans. No oceans is... It's anyways just blue, kind of, so... and you know, you have to imagine a drone flies for an hour, so you actually need ships to land the drones between the different, so oceans is also out of the picture. And I think the commercial usage of oceans might be a tiny little bit limited unless you do a search and rescue mission as they did with one of the airplanes that got lost. Yeah. Okay, so now I have to cut you off because I want to get this through. Resolution. There is some people which don't really know what resolution is. So that's why we included a little definition here. I mean, there's two aspects of it. There is the beautiful part of it, to just make an image very beautiful, and then there's also the aspect of information. And for us, the information part right now is way more interesting than the aesthetic part of it. And there is two effects you really have. One is pure precision. So because we can capture more than the human eye, we are actually in this position that we could potentially achieve lifelike 3D. Yeah, for that simple reason. If you would below it, it would be way harder because then you have to put in some intelligence and some black magic, which normally doesn't work, and it would be fucked up. The second part, which is really, really important, is it's much faster. So, of course, you can also just take a normal camera with 20 megapixels and scan this room, and you just take the images way closer and with a very good optic, and then you have to take 20 or 40 times the images than we do. So this is the second advantage. You can of course kind of generate that much resolution, but you just need 40 times the capturing time, which for a lot of cases is not feasible. So this is an image from the first prototype we basically took. We had 3 different cameras. So we had an Nikon full frame DSLR. We had an iPhone 6. It was mine, so it has 8 megapixel resolution. and our system, and we took it from the same position with the same field of view, more or less, because iPhone has a has a narrow field of view, so we actually had to move closer. So that's why the image is a little bit better than expected. And this is the amount of detail we still see. So we can still see from this image, this is even a crop, and from this little crop we can still see all the written letters, and we can see all the details. So it was taken, the camera was 6 meters away from the object, and when you see this plate, there is these fine lines, and we could see per line more than 100 pixels. Yeah, so on a line which is a millimeter in surface, or a square millimeter in surface, it would still have more than 100 pixels. Yeah, and that really gives us that detail which is giving us an advantage. So here you see also, which is really interesting. So when you take the Nikon and the iPhone, the Nikon has twice the resolution, but Apple does such a good job in post-processing these images automatically, because we took the images, I mean, all images, all the three, are not post-processed. Yeah. So, and there you can see that the difference between the iPhone in the end as a result and the Nikon is not very big. Yeah, at least visually. If you analyze the pixel size and so on, it completely falls apart, the iPhone image. But purely visual, the difference is not that big, and I think this is also one of the big reasons why the whole camera industry is in deep shit. Sorry. So this is now this is the where magic starts to happen. So when we talk about 3D reconstruction, then most people are just in this bit basically, in this upper layer, where we take images from different perspectives, and then you make the geometrical 3D reconstruction, you get a point cloud, and that's it. But from the very beginning, we said we want to take this one step further. So 3D data really gets interesting once you have context. So once you understand this is a bottle, and I can basically, like in a 3D model, I can take this bottle away and replace it with another bottle which is standing like this. Yeah. And then we kind of have this interactive moment. So if we have a 3D which has elements, which has objects, which has a certain intelligence because it understands context, because it understands it's my bottle and it's half empty, so the robot could bring the new one which is full, then we have context and we can have interaction. Yeah, and also for a game, the important part is we extract from the 3D models in the end, we extract these objects, feed them in a database, which creates a feedback loop that more 3D models you have in a database, the more reference models you have, the more accurate your 3D reconstruction will be. Yeah, so you have this positive effect loop, and on the other hand, your business will increase because now you can start developing a game in hopefully 10 years from now. You say I want to do it in Paris in School 42, and I can simply go on a database and get all the 3D data, get all the objects, and I can start placing different objects from maybe Harvard. Yeah, and then I have a kind of a combination between School 42 and Harvard. If you would want that, that's a different question. But so this is basically moving forward in really having a deep understanding of your 3D surrounding. Yeah, which of course technologically this is a huge step. Yeah, I mean especially in this lower layer. There comes a huge part of understanding in, so of somehow artificial intelligence. All these factors basically come in, which makes things extremely complex. Yeah, but it also makes them extremely interesting because you have to solve extremely tough problems, and you have the opportunity to actually be one of the first people to work on this also with the resolution and everything. And what we really believe, the last part is database, is what, like from a company perspective, will be the biggest hit. Yeah, because then you have a very, very scalable business, and you have a lot of applications which can simply access your database and get that through. Yes.
You're having like a big, like an AI, like deep learning, like analyzing all the photographs and images and putting all the items in the database.
Yes, I mean, this is something, one of the future challenges we have. Yeah. So we're actually looking for people, which will start that kind of project in the next 6 months. Yeah. Yes.
Will we be able to use the database for 3D printing?
Of course. That's one of the applications, yes. Yeah. And also, I mean, at some point, maybe we have a camera out so you can scan your cup at home and you can 3D print it. Yeah. Other question? Is this clear? Because normally this is like, people go like, huh? Like, what the fuck are you doing? Yeah, yes. Yeah. Among others, yeah. No, I mean, this is, I think, where, this is what always sometimes people have difficulties to understand. The camera is just the first part of it. That's just the first key to actually unlock a much broader problem and a much broader application as well. Yeah. And this is also the topic where so right now we basically, this is what Isaac will also present, we investigate a lot on this part to basically first understand what is a normal 3D reconstruction. But now we're already kind of want to in parallel build more or less two teams, one which will be working experimentally to a product that might be there in 3 to 4 to 5 years, which is really, really cutting edge, and the other team which is more implementing and more focused on finding fast solutions which are working now. Because as a company, you always need to kind of have these backup solutions. I mean, you cannot work on something which doesn't work for 5 years and then suddenly it works, if you don't in the meantime have results that you can present investors and also clients. And that experimental part is where you need the really special people. And the creative minds, the ones which have different backgrounds, which bring new ideas to the table, and so on. Yeah. Yes. No. So this is basically for simplicity. So as I said before, so this gives a positive feedback. So the bigger the database is, the better the reconstruction is. But it will be kind of a hybrid system that in the beginning we will use existing databases which are not as accurate and as complete, because there is right now unfortunately no database of 3D objects which has a high consistency in quality. So we talked to different furniture suppliers, architects and so on, and they all have the problem that the databases, they really vary in quality a lot. So you cannot really reliably actually use them. So this is why we're now, this is the virtual systems project that Sebastian will be talking about. We're actually starting to create, or we created a tool to be able to make this database and this feedback loop in a virtual system, so that we simulate it first. And then from there slowly start to basically from the captured data that we have to implement it in a real system. Yeah. But so for us, this whole block is in the end the 3D reconstruction. Yeah. Yes.
Is your 3D model doing a subtraction of object to such as you are in a train station and you want to remove all bench or chairs?
Ideally, yes.
How do you feel also?
Yes. Big question. So how it looks right now is also there, database helps a lot, and the geometry helps a lot. So you have some geometrical rules that you can use for this infilling, yeah, as repeating patterns, as detecting the big geometrical lines, and also in the 3D reconstruction already recognizing, and that's the first step, that's a bench. So that's the first step you have to solve, because without that one you cannot subtract it. Yeah. And that step to recognize the object in 3D and really have a reconstruction in the end with all the objects or all the elements categorized will already help us a lot in this step.
So could you map a place where there will people?
Well, then you, yeah, no, but then you kind of get into the boundaries of physics. I mean, of course, not everything is possible. I mean, if you just have if you cannot capture it, like the ground, for instance, because there's so many people, how do you want to reconstruct it? Yeah. So the same also with forests. It will be really tricky, but forests are not. It's different. So commercially, they're not that interesting. Yes.
And then we are moving from Lifelike 3D to like 3D world that doesn't exist 3D, that we are replacing anything.
Yes. Yes. So this is kind of the interactive that we have, but it's also something which is much more interesting from a planning perspective. So this is really interesting. For instance, if you take indoor spaces, then you can, with one click, you can say, I want to remove all these benches, and then I can refurbish the room. So this kind of going back to zero is from an applications point of view really, really important. Yeah. Also, if you have, for instance, an apartment you want to rent out, you can simply scan it, you remove all your objects, and you go like, okay, this is blank start. Yeah. Yes.
You have only one photographic module. So how do you tackle the problem of depth of field?
As I said, we have to take multiple images. You always have to do it. Yeah.
But from with different focus.
No, with different field of, with different angle of use.
Yes, but you have to focus on each object.
Mm,
Do the same for each object.
Yes, this is one of the other beauties of our system. So we have a very large focal range, or range which is in focus. So very unshallow depth of field, a very large depth of field. And everything which right now is further away than 5 meters is in perfect focus. So for cities or for larger applications, it's not a problem. Yeah. And then we'll have two settings, one for everything which is up to 10 meters and everything which is further away than 6 meters. Because you need to have it in focus, otherwise you cannot reconstruct. So this is a marketing slide. Yes, we are convinced, to remind the people again. So this is actually like so this will be or hopefully the first commercial product which will have around 1 gigapixel resolution, and that's a comparison if you just map the pixels basically, and you just like sum up the pixels that you have, and then you would have this kind of size. Whereas a Hasselblad for $35,000, this kind of big ass camera with a 50 megapixel sensor is this. Then you have the Canon and you have the iPhone. So it's kind of a little bit of a jump. Now, how do we earn money is not such an interesting topic for you, but I still want to talk about it. So as you already said, we want to sell the 3D data in the end, not necessarily the device. Yeah, the camera is one project on its own. If the market is ready, if we are ready, then we will sell it. But in the beginning, it's really about the 3D data. Total market size is approximately 280 billion. That's pretty big. That's bigger than the whole smartphone industry combined. That's a different markets. That's also not something which is for you guys too interesting. All different kinds of applications that we can do. Now, this again is something maybe a little bit more interesting. So, consumer device, it's something we actually started the whole project with this in mind. And then we realized there is something which might be more valuable than a consumer device. Right now, for us, it's really the acceleration unit. So if we sell a consumer device, if we sell a camera with that kind of resolution, we actually have the opportunity to accelerate the data business. So more people using the camera means more people generating 3D models, means more revenues, bigger database for us. And this will be the most important factor. Then on the other hand, you have 60 million units sold every year, which is a lot. So that market, of course, also is quite big. And then you have the usual suspects, licensing. Other big companies already approached us for a smartphone module. Possible, but right now not our focus. Yes.
Would it be also an independent device? Could it
Yes.
be kind of smartphone accessory like the scanner?
Yeah, I don't like these smartphone accessory kind of things, personally. I think they're not cool. It's that simple. And I don't know if it makes that much sense in this setting. Then I rather would make a smartphone. Yeah, then rather incorporating a module in a smartphone. I think that's the smarter solution. So to have a maybe 100, maybe 150 megapixel module, I think that would be possible. So quick stuff, corporate, that's the founders. We have, this is already more now, the nationalities. Most of them are engineers. So we have the 3 founders, which we take out of the engineering team because we do other stuff right now. So except us, we have 1 person doing the marketing, communications, social media, presentations, everything. So she's in deep trouble with too much work. But the rest is all engineering people, from hardware engineering to software engineering. The whole bandwidth. We have quite a lot of physicists. We have quite a lot of mathematical background people. Yeah, so a very wild mix, not only from the nationalities but also from the backgrounds. This is the timeline. So we started in roughly 2014 with the first idea. We raised some money. We'll raise some more money, and then some more money, and so on. So this is the usual game. We're part of the Hardware Club. You might have heard of them. I think they were also once here. It's a club from Paris, which supports all the hardware startups worldwide. So it's a community of hardware startups which is helping each other. Really, really, really cool. So if anyone in this room is ever planning to do a hardware startup, these are the right guys to talk to. They can help a lot. Yeah, the rest is not so interesting for you. These are our partners. We have a really good partnership with the Paul Scherrer Institute, which is, so you maybe know CERN, the research facility in Geneva and below France. With the particle accelerator, that's a small version of it, and in some parts it's more advanced than the CERN. As I said, the Hardware Club, Entrepreneur Club of ETH, of the Technical University of Zurich. And then we're part of this Innovation Park initiative of Switzerland Innovation, which has been announced on Monday. And we're the 3rd startup being part of it, so we're super proud of that. Yeah, come on. So what is the time now? Because I think we used way more. Way more than we planned to. So we used 1 hour up?
Yeah, more than 1 hour.
Okay. How are you guys doing? Good? Good? Okay. So I will make this short. I just need a sip of water. What it actually is to start a company, because I think maybe to some of you this is interesting and important. So this is getting a little bit off topic, because then the other guys are talking about technology again. So this is different topic. So one thing I get asked a lot, how do you assess, is it a good idea? First of all, you can't. Second of all, I think that the only measure you should take, or you should really analyze if it is logically makes sense. A lot of ideas sometimes make logically no sense. And for instance, a bad idea is something that only works if it's big. Yeah, so social network. That's a bad idea. Now, why did it work for Facebook? Why was a good idea there? Because they used very small units. So they used universities. So that was a very small unit where you could have a critical mass really fast, because it's a very small community where everyone knows each other. And then they grew from community to community to community to community. And at one point they had so much small communities that in itself, or as a whole, that community of small communities was big enough to be a community within the whole population. But generally these critical mass problems, they suck. Yeah, because they're really hard to achieve, because you need to be big in order to make them work. So this is something when people come to me or people ask me, I always tell them, be cautious. Yeah. Or figure out a way how you can make the community really small, and how that community has a lot of communities within a society. Yeah. So this is the only thing I can say to that, because there was a lot of ideas, or still are a lot of ideas in this realm. So I just want to tell you, be cautious about that. The other part is, for me, a startup is something, or is a company or an idea that has its potential in the future. It's something where the potential is not now, but it's a potential which is in the future. Because chances are that if the potential is now, someone already thought of it 5 years ago, already is building for it for 5 years, and when you just start now, you're probably too late. Probably, yeah. You can also be too late when you start early, and someone started even earlier than you, yeah. But chances are that not that many people make the long shot and take the risk to build something for the future. 1 second. And the other example I always give is now I have to, that I don't mix up the numbers. Just a second. So if you take 30 steps, yeah, just normal 30 steps, linearly, how what is the distance you cover? 30 steps. Roughly 30 meters. So what if you double? So if you 30 times double, how big is that distance? So if you have exponential growth, that's 70 times around the Earth. Yeah. And this is what is happening with computational power. It's doubling, and this is the exponential growth that you have with a lot of industries. And we humans, we simply cannot imagine exponential growth. It's super hard. It's super, super hard. But if you find something where you see exponential growth, you have to take this into consideration, especially when you build something for the future. Yeah. So we know now, or we try to always give this further. Imagine what will be the capabilities of computers in 5 years. The jump will be like at least as big as from today back to the 90s. And I know you guys are much young, or probably much younger than I am, but back in the 90s, computers sucked big time. Yeah. So that jump from there to today will happen in the next 3 to 5 years. That same jump. Yeah. And you always have to keep this in mind when you build something for the future. Then another big point is technology versus market. Market always wins, always. If you build an awesome tech and no one wants it, meh, yeah, then no one wants it. And in the end, the customer is always right. So you can say, yeah, but no, he doesn't get it. In the end, the customer is the one that buys the product, so he's always right, or she. And a good example was Segway, where they simply thought, well, we have a new concept of transportation for cities. And yes, they're right, it's an awesome tech. It's super cool, but they completely missed the marketing part and completely missed actually introducing it to the market, and completely missed that they have to change the behavior of people in cities. And that's hard. 99.9% in the cases, changing people's habits is way more difficult than building technology. Yeah, yeah, but you always come from a different perspective. Yeah, so a lot of tech is coming out of universities, or also from people which are every day around tech, and they have a different community. Yeah, and you always have to be careful. And this is also a little bit that people talk about the Silicon Valley bubble. There, everyone is awesome. Everything is awesome. Everything is cool. Everyone buys the newest tech. But the Silicon Valley is a very small portion of the world. Yeah, so if someone in Silicon Valley, there's a lot of people run around with the stupid Google Glass. Did you ever fucking see one Google Glass in Paris or in Zurich? I didn't. Yeah, or maybe at the tech meetup. Yeah, one guy, and then everyone wanted to try it, and everyone was like, huh? So this is really important. How to start? Number one question I get from a lot of people: Nike figured it out. Yeah. There is in the beginning, the steps are really small. It's really like, it's really, and sometimes you lose a lot of time between the steps because you don't have the right people, because you're not sure yourself what you're actually doing. You have insecurities, everything sucks, you don't have money, you don't have anything, and it's like, yeah, but you just have to get through this. And it will never be easier. And then you say yourself, if I would have money, I would do it. It's an excuse. I'm really, really sorry, but it's an excuse. It's the same that saying founders, that's us building the new office. The most important part is not the number of people, or 4, 3, 2, 5, whatever, who cares? It's that you have a team where you have different roles. So you cannot be a team with 3 visionaries. Not going to work. You cannot have a team with 3 tech guys. Probably will, maybe it will work somehow because you can somehow pull it off. But the team which would have a higher chance to succeed is one that has a tech. You need a tech guy, no questions asked. Probably you need a visionary, and you need some financial guys, or a marketing guy, or someone. Like, you can also build a team with 2. That's also good. Don't do it alone, because it will be the hardest thing of your life. It will be so painful, and it will be so many hours. And if you just do it on your own, at some point you will pass out, and you want to have someone else at that time going, that the company continues. Yeah, because you will need like a week to recover. Yeah. So, which was for me between Christmas and New Year. I was basically just lying around. Yeah. Recruiting. So this was Entrepreneur Club specific for ETH. Find the places where you have relevance. So ETH has this event where it's called Startup Speed Dating, where they basically bring startups and students together. They have the speed dating event, so you have 6 minutes to talk to each other. That's the perfect setting, because the people coming there, they already have the expectation to talk to a startup, and you as a startup get the right technical people. Always go to the environments where you find the people. If you need an economics guy, you shouldn't search in a technical university. Chances you find that person are really low. And this is the difficult part for recruiting and also for your founders. You have to leave your friends of circles, you have to leave your comfort zone, you have to leave the social peer, because otherwise you will not get people which think differently. This is key. Funding, to be honest, it just happens somehow. It's one of these things you cannot explain how everything falls into place. The most important part is you have to talk to as many people as possible. If no one knows about you, no one will come to you, and no one will give you money. The more people, it's a simple numbers game. The more people you talk to, the more people you have, the more people will potentially invest. The average rule, if you have between 20 and 30 discussions, in the end 1 or 2 people will invest. Average. Sometimes it's a bit higher, sometimes it's a bit lower. If you know the people really well, the chances are that it's much higher. So that's why normally you start with your friends, your family, the famous fools, so people which already trust you. Funding is a big game of trust. Yeah, if the people trust you, they give you their money. Otherwise they won't. So this is why it also needs time. You cannot just simply go and say, I need money. Now, I have an awesome project. Yeah, a lot of people have awesome projects. So you need to plan time for this. Normally it takes around 6 months. The first funding round we pulled off in 2 months, so it was extremely fast. But it was also because we knew the people, and the people already knew about the project. Yeah. So we're now going, in the next couple of weeks, we're going to the US to plan the next, so not the next, but the after next funding round, which we might want to have some US guys with us. So that's in a year. So we're starting to go to the US now. Yeah. And this is I think the difficult part in a startup, that at one point, and it also happened to us, there is so much work and you completely get thrown over with work, but you always have to think ahead. So you always have to be 6 months ahead of everything, because then you can still fix things. 6 months is a time where you can still fix a lot of stuff. But the moment you have like, oh fuck, next month we need a demo. No. Or next month we don't have money anymore, we need money. Then, and this is the most difficult part. To be or to manage the workload you get suddenly in, because you will get overthrown with emails and with stuff, and at the same time still be able to be ahead. And this is why as the founders, you have to find a way to I know this is always the bullshit that people say, to delegate your work, but you have to find space to think and to allow time to process all the information you're getting, and to stay this 6 months ahead. Legal and accounting, it sucks big time. I hate it. Yeah, it's expensive as hell. It takes time. It is unproductive because you freaking lose money, only that you're allowed to actually do a business. It's the worst. It's a nightmare. But it's also super important, and you have to plan a lot of cash for this. Yeah, this is really, really, really expensive. And you will be surprised, and there's these rumors that France and you know, bureaucracy and so on is not. So yeah, even in Switzerland, this sucks. Yeah, really, really big time. And one advice there, I know this is sometimes uncomfortable, but be clear from the very first second. So this is my one advice I can give you when you talk to lawyers. You somehow try to fix with them a budget. They will hate you for this, but you say, guys, okay, if we are, this is what we want, this is more or less the timeline, this is the budget we somehow have, tell us if it's more. And do you want to have this written? Because they will send you a bill which is way more than what you kind of agreed, and then it's like, yeah, but we never really agreed on it, and so make it clear and be tough from the very beginning. This is my only advice I can give you. And this also applies to employees, this also applies to your founders. Everything you have to fix afterwards will cost you 20 times the amount than if you fix it from the beginning. Yeah? And puts you down a lot of time, a lot of energy, a lot of stress. You don't want this. Really, you don't. You probably will not be able to avoid it, but at least I can give you the stupid advice. Productivity, I mean, being busy just forces you to be productive. For me, it was this little book here. Yeah, so getting handwritten and analog again, this helped me a lot. Everyone has to find its own way. There is no general purpose rule, I think. So don't spend time on, I mean, don't spend time on finding tools to be productive and to-do lists and whatever. Just do. Just go. The time you spend on figuring out how you are productive is time you don't spend on your company. Because at some point you don't have time anymore, and that makes you productive automatically. So you can be kind of Darwinistic in this approach and simply wait until this point comes, and then productivity will be not an issue anymore. You won't be playing games anymore on the toilet, you won't be doing I don't know what, because you simply have so much work to do that every minute you don't do it, the inbox gets bigger. Success, for me, so I was an athlete before, and I had the luck that I could practice with several world champions, vice Olympic champions, European champions, and so on. It's the sum of all the small things. So the sum of all the little details that combines together in the end makes a big difference. Where you say like one company is like, wow, they're like light years ahead of the others, and it's in the end it's only the sum of the small things. And of course it's also consistency or persistence. You just have to keep on going. Also, if it's difficult, I think there is no company which didn't face really difficult times, where they were so close of being closed. I think this simply doesn't exist. Yeah, so you have to be extremely persistent, extremely resilient to stress, extremely resilient to external factors. Then you have a chance, and then you have to kind of fix all the small details that they're working well, like a Swiss clockwork. Another thing, process versus moments. There are no moments. There is not this moment where you're like, I did the fundraising, now I'm happy, now I'm like, yeah. Of course, that's kind of your goal, the IPO or whatever it is, or also for an athlete to win Olympic gold. But to everyone you talk, if you only do it for this one moment will pass so fast, you'll not be happy, and you will not have the resilience and the strength to go all the way. So if you really like the process, if you like the way to get there, and if you really like this, then it's something for you. If you do it only for the fame that you're on the title of the New York Times or whatever, or of Wired or of TechCrunch or I don't know what, that would be a moment of glory, of I don't know what, the moment of fame. If this is for you, then go to entertainment, but not to start a company. That would be my personal advice. So you really have to like the process. You have to like every day to go to the office and push yourself, your founders, your team, everyone. If you love this, then it's the right thing. Yeah, last but not least, one of these funny memes. Yeah, that's reality. I can confirm that. Yeah. Okay, so this is my personal contacts, but you will see this again afterwards. So we have no business cards because we ran out, and yeah, business cards in the startup life are not as important as other things. So if you want to get in touch with me, write it down, take a picture. I'm available via email. I get roughly between 100 and 150 emails a day. So if it takes 2-3 days to reply, I'm sorry. Yeah. But if you put School 42 in the subject, then it will be good. Yeah. Any questions to this? I know this is much less technical, but yeah.
A lot of questions regarding this. Thank you for sharing all this.
Mm-hmm.
What are your challenges for the next days, 3 weeks, and next 3 months or 5 months?
From what perspective? Technical or company-wise?
What you have in mind when you think about next 3 weeks and next 10 months and 3 years?
I mean, on the very short term, I think it's always that the whole company is always working in the same direction. I think that's a constant. You have to constantly be updating this, and you constantly have to kind of be aware of that. We have to coordinate a lot of technical development, that it's in line, that this part is covered, that because we have these two streams, hardware and software, right? And somehow they have to float together, and we're still not well enough in this. We have to fix our internal communication, which is much harder than you would think to do. It sucks. Recruiting, I think the process of recruiting is getting to a point where it's good. What is still, I think, not yet there, which is for us the biggest problem right now, or not problem. I mean, this is something we have to fix rather short term, is how when new people come on board. So for the first time we had new people coming on board, where there was already a code base, there was already material, and it took them a month to basically kind of get acquainted with everything, get into the company and that stuff. That's too long. We have to somehow cut this through and make this shorter, because a month's salary is a lot, and a month time-wise in a startup is also a lot, and you normally have 3 to 6 months for recruiting to actually get someone in. It's the whole process it takes, from the first interview until the people is actually sitting in the office. Sometimes even longer when you have to file for visas. And then you want them to start being productive from the second or third day, basically. And that's really, really tough. That's extremely hard. And if you want to scale up from 14 people to maybe 20 people or 30 people in a short amount of time, you first need to fix this. You first need to have a process in place that can deliver this. So I would say that's the next 2 months. And then, of course, funding is always a challenge, always. I think the first 2, 3, 4, 5 years of a startup is a constant search for money. Yeah, I think this is the most urgent stuff in my mind. I mean, and you can already see it. It's already shifting for me a little bit away from the technology, more on how do you actually build a company, how to make this whole group work, which is extremely interesting at the same time, but also there is no rule for that. There is no book you can read, because individuals are always a little bit different, and you have to learn on the fly, and for learning you need time. Yeah, so that's the frustrating part, that you have to kind of be okay that certain things simply need time, and you cannot accelerate them. Simply experience you need to gain. But yeah. You first.
How could you explain that? Well, I mean, in the camera industry, I think the most advanced camera are about, I don't know, maybe 20 megapixels. And how is it possible that two guys in the garage created a camera that is 40 times better?
I ask myself this since 3 years. Yeah, there is. I mean, I said a little bit. I mean, we're going in a different direction than what the other guys are doing. So maybe it's that. It's a little bit destroying their business model. So a normal like camera manufacturer, they're not in the data business, first of all, but they're in selling a device business, and they're not selling in a device business. They're in the business of selling optics. So this is what a lot of people don't know. So they sell once the device, and then they sell the optics to it. That's where they earn their money. And with a system as we are building, with that much resolution, you don't need exchangeable optics anymore. You simply record at 120 degrees field of view, and afterwards you crop yourself the part of the image you want to have.
Yeah, but if Sony would want 800 megapixel camera, they could do it in months.
No. No. I mean, big companies. I mean, this is what we learned also in the past months. They have the resources, but to get everything going in these big companies, oh my freaking goodness, it takes time, because the budget is not there, and then the budget needs to be this, and this guy goes like, I don't want to see it, this budget goes there, and this guy who decides on the budget thinks the project is shit, and then so and in the end, I mean, the market is big enough for more than one player. Yeah? And if a big one is bringing something out, I mean, we're in a very good position to go to all the other players and say, hey guys, you can now develop 2 years, spend your R&D on this, or you can simply license the technology from us, and you have it the next day. Yeah. So this is not something you have to be necessarily afraid of. I mean, Tesla was building an electric car, and there's like tons of car companies out there. And I mean, I'm there and I'm asking myself, why is Tesla on the market with an electric car and no one else? Yeah. I don't know. It's kind of a rule of life. I don't know why. I simply don't. And then to also answer the next question was, what do you do if Google does it? Yeah, well. You can always ask this question. You can never answer it because Google is so big and Apple is so big. I mean, of course, that's one of the things you have. That's life. That's risk you have to take.
I think it's a sort of business model for those companies to make more money, to propose a device that's not that cheap.
Probably yes. Yeah. Yes.
You plan to sell your entire mapping technology, or just
So the question was like, if we plan to sell the entire mapping product as itself.
like if someone wants to map
We're always happy to have partners. I mean, we cannot do everything ourselves. I mean, there is one part which goes more in the insurance direction, and we might even, with one of our investors, we might co-found a new company, which is simply doing that. only that, because we say, yes, there is a huge opportunity. He knows the whole insurance industry really well in Switzerland. Why not let him go and do this? It's way, I mean, be my guest, because we don't have the time, the focus, anything for it, the money. Yeah, so always for these things, when you don't want to do it yourself, you can always, or partners are really good. Finding the right one is the other question. So now I will head it off to the other guys because they're waiting for so long, and at one point they probably were nervous and now they're not anymore, which is good. So yeah, I will give the word to Isaac and Sebastian, who will give you a little bit of an insight what it is to work at a startup. They both joined, Sebastian joined a little bit earlier than Isaac. Isaac is an intern at the moment. He's more in the 3D reconstruction space, but they should all tell that themselves. Give them a hand.
Thank you, Nielsen. Actually, do you guys want to take a break? No? Okay. Okay, stay here, stay here. Okay.
They're not coming back.
So actually, Sebastian will start, I think.
Yeah. Can you set up the computer?
Yes.
Actually.
Yeah, it's on this side. The way. Alright. Good.
Okay, thank you, everybody. Well, I mean, Nielsen talked a lot, so I mean, we will try to do it a bit faster. The idea, I mean, he talked about the company, the division, and everything. The idea is basically maybe to show you a bit more what it is like to work, well, in a startup like Nomoko, for example. So we'll show maybe a few of the projects we are working on. Obviously, we cannot go too deep in some technological details for some confidential purposes. But whatever. So I am Sébastien. I graduated in physics at EPFL in Lausanne. So I speak French, so we can speak French afterwards if you want. But my boss is here, so I have to speak English. And so yeah, I've been employed in Nomoko since middle 2015 approximately. And Isaac,
Yeah, hi, I'm Isaac, or Isaac. I studied, or I'm still studying robotics at ETH Zurich. And Nielsen already talked about the startup speed dating. That's how I met Nomoko. Shows a picture here where you can see me with the camera. I'm interested in photography, of course. And there the talk was more like 30 seconds, not 2 hours. So, but still already I got interested. And I started in September, and I will stay with Nomoko for about 6-7 months. Now it's a bit longer than 6 months that we initially thought, because just doing one more project with a robotic arm. And yeah.
So we really like this picture. If you don't know it, that's the default picture for this Mac application, which I forgot, Keynote, whatever. So our roles in the 3D team. So there's obviously a hardware team. We are more working on the research for the future applications. So it's really kind of a research work. For example, we are working on implementing a way of simulating the camera system we have in some real-world applications. We also have obviously to implement and test many 3D reconstruction algorithms, many 3D reconstruction methods, and obviously to test what already exists and what is possible, what is not. And Isaac will also tell you about an automatic calibration setup that is creating right now. Yeah, thank you. So just a small reminder, because I don't know how much background you have on this, but basically camera, this is, it's just a way of, projecting the 3D world on the 2D plane, right? So when you look at this model, it looks pretty simple, right? There's just one equation with one matrix. The thing is, it's never as simple as this, obviously. There's multiple parameters: sensor resolution, pixel size, focal length, to name a few. And so, well, one of the first things we did, I mean, I did when I arrived in the company, typically, was to, well, create with MATLAB, because I'm an engineer, so I like MATLAB, to create to create a model for, well, basically dealing with all these parameters, trying to find a way to optimize all these parameters with respect to the other, because we don't build everything ourselves, so we have to choose what kind of optics we are going for, what kind of materials, etc., etc. So we have to find a way to, well, optimize all these parameters together. So that was kind of an engineering task. I will not tell much more about it because it's getting quite confidential at some point, I guess. All right. The thing is, at some point we were like, okay, well, we have this virtual way of representing our camera. What would be good is, well, to see what the camera sees, I mean, to simulate what the camera sees. So we could, for example, render 3D data to simulate what the camera sees. Obviously, you're going to say to me, well, there's a lot of softwares for that already. And there are, so we chose the simplest one to use, which is called Cinema 4D. It's a rendering software. It's mainly used by artists and I would say graphic designers. And so we used it because, well, it's really simple to render scenes in there. Obviously, if you want to render a scene like that in MATLAB, you have to, well, implement a ray tracer yourself. It's not, it's quite useless, I guess. So we created this plugin in Cinema 4D, coded it in Python to, well, simulate all the views from from what our camera sees, and also all the parameters that are a bit more complex and not implemented in there. So we also simulated lens distortion, all the effects coming from sensor noise and stuff like that. So typically we have now this plugin, which is pretty useful because we can now, well, test it in kind of virtual situations. So we create a scene in Cinema 4D, for example, and we put our virtual camera in different positions in the scene, and then we can simulate perfect data coming from our camera and test it with our 3D algorithms. The idea here is that, well, when you don't have, for example, the prototype yet, or you want to choose to have some design traces to do with the prototype, well, you can do these by knowing before, okay, well, in this kind of situation, you would like to have maybe these kind of parameters, whatever. And with these, well, you can, typically, yeah, that's, for example, one simple example. So you have this software, Cinema 4D. You place your cameras in there. You can create different renders of one object, right, from different scenes. What's also really important is that you can create these ground truth depth maps. Basically, so a depth map just maps right to the distance to the camera. If the color is brighter, it means that it's further away. If it's darker, it means that it's closer to the camera. Do you have some water? Yeah.
Yes.
Wow. The Swiss cup. Thank you. So let me show you a bit how it works.
So maybe quickly, like, why did we use, or was it necessary to have that reference 3D data, right? So basically, when we need somehow, so we want to test 3D reconstruction algorithms. So somehow we need to have a way to check the quality of the reconstruction algorithm. So we need to have the ground truth. So for any object you just scan or you just take an image from, you don't have the ground truth, or you measure it, right? So, but measuring it.
So we really use it as a testing mechanism. So basically, if you have a 3D model that you already know all the parameters of these 3D models, with the plugin we created, you can obviously easily put some cameras around there. Let's choose some quite classical composition, right? So in all of these cameras, we can actually simulate the parameters we have with our camera, right? And you can render. Well, this is probably a bit too close to the car, but you can render the views of what the cameras would see, right? And then, as Nielsen said, you reuse these images to create, to use them with the 3D algorithms to create the 3D reconstruction, and you assess the quality of this 3D reconstruction using the data from the initial 3D model. And basically what's really great with this is that, well, now we have a way to create like a big database of 2D renders of 3D images. So basically we can already start thinking about how we can use, well, big databases of data sets for deep learning at some point. We don't have anyone working on this right now. That would be a job for someone, obviously. And so yeah, that's typically the kind of things we want to do with this. So let me show you, just as a transition to our friend Isaac, let me show you the kind of stuff we can do in with a really simple 3D reconstruction and with simple 3D models. See if, for example, meet this really sad woman. She's called Lisa, and she was just divorced, right? She lives in a really crappy apartment in Zurich, and she has really bad taste in decoration, as you can see, right? She has a really strong sense of humor, though, and she really likes to wear these kind of hats. That reminds her that her life used to be not so miserable. Fortunately, she lives with her friend, her Velociraptor pet, called Philip. So now, for example, you have such a 3D scene, right? And you place the simplest 3D rig you can take, right? So the simplest way of taking 3D pictures is to put a stereo rig, so just the left and the right image. Starting with these two images rendered, we can now work on making some stereo reconstruction, which is the simplest 3D algorithm that we have, for example. And now Isaac is going to show you what he did with this, for example, and well, give you an idea of what it's like to be an intern at Nomoko.
And, questions? Do you have questions?
Do you have any questions? Sure.
Will you or Isaac show the rendering of the car? You put a lot of cameras around the car.
Ah, yeah. Well, that's
See the result.
typically that's a rendering, right? But I mean, if you want a big one, where is it? Bam. So typically what you're going to have, I mean, the rendering software, that's obviously what there's nothing, yeah, there's no light in this scene, right? That's what happens when you do things live. Okay, let's put just a small light in there. Whatever. Up.
So this what you see here is kind of the preview of the whole render. So basically it uses OpenGL to just render a few polygons. Well, here the ray tracer actually calculates all the light rays. That's why it's so much slower. So this is kind of real time, and the rendering is of course slower, but it's also of higher quality, and we can better control all the parameters. And yeah.
So the light is really dark here, but whatever. I mean, what you can see is that the render, I mean, we use it because it's useful to, well, render all the like reflections, shadows, stuff that happens when you have light, for example, which we don't really have right now, but and do we have, I don't think we have the point cloud of the car here, but yeah, unfortunately we don't have it.
It's on the other computer, I think, on the other hard drive.
All right, well, we will show you Lisa first, if that's okay with you, then some other examples. Other questions? Yes?
Right now, what's your
Well, it really depends on the algorithm that we use. So basically, we are still in the research phase for this. We are considering multiple solutions. It really depends also on the configuration you have, what you are scanning, what you are going for. So it's kind of difficult to tell. But I mean, I would say, I mean, it's really precise depending on the important factor here is the, well, the setup you're testing. Is it constrained or not? Is it controlled? So if you're outside, it's obviously more difficult because there's a lot of uncontrolled things you don't see coming to you, right? So there's a lot of light everywhere. You cannot control the lighting, you cannot control the position of the object, you cannot control a lot of things moving in the scene and everything. So that's
question is also, how do you define accuracy? Like, you have this ground truth model and you have your result. How do you say this is a good model? How this is a bad model? Do you take the closest neighbor, like the point distance, or how would you define it?
You can take closest neighbor. It depends what you want. In fact,
yes. French.
En moyenne, vous devez prendre tous les paramètres possibles pour faire en fait une moyenne globale, parce qu'à un moment vous allez devoir la faire, vous allez devoir y réfléchir, vous allez devoir pousser ce point plus loin. Aujourd'hui, qu'est-ce que vous avez concrètement en termes de pourcentage d'erreur? En prenant le point qui vous intéresse le plus, celui qui est vraiment aujourd'hui votre problème, qu'est-ce que c'est?
So the first problem, what he already said, is you have to define. So the first step is, so we have created the virtual systems to the point that we can have, so we did everything until the rendering and the 3D reconstruction. So the last part on the comparison is not done yet. So we have to find a way to actually compare, or we have to determine what is the tool of measurement, exactly as you said, that we can actually measure that percentage, which is not straightforward. It seems a really easy or kind of a straightforward problem, but you can look at different things. You can look at the point clouds, you can look at the depth maps. There's so many things that you can look at. And for us humans, this is super easy to compare two things, which one is more accurate. If you have two point clouds, you can say like, yeah, this one is better than that, kind of visually, like this. But to really determine it like scientifically, if you have a good solution, then we can talk afterwards.
I will also show for the Lisa scene, I will show you the point cloud, and you can see that there are a lot of like shadow areas where you don't have any data, so you can't really assess an error for that. If you just leave it out, you can get really, I would say, pretty good results actually. Okay. Anything more from your side?
No, I think you can.
Okay. So I'll just continue from here. Yeah, well, just very briefly, just to give you again a reminder. Before with the camera, we go from basically a 3D scenery to a 2D image. And now what we're trying to do is the opposite. So we try to have a bunch of images, and we try to get the 3D back from that. So we reconstruct the image, the 3D, I mean. And just as a comparison, here we have a laser scanner. They use time of flight, so they can use, it's called a one-shot technique. So they can take one shot and they can get the 3D data. Whereas we have to take multiple shots. And then we use this geometric approach using triangulation and epipolar geometry to infer the 3D point. So if you have a left camera, this would be the image plane of the left camera and the right camera. And they both see this point X here. And this camera sees it here at X1, and this camera sees it here at X2. And we know how these cameras relate. We can calculate where the point X is. And we know that it must be on this line, for example. So we can use some constraints to make this problem a bit easier. And this really makes the problem tractable in itself. So the simplest setup again is stereo setup, as we've seen before. So in the first months I came to Nomoko. I'm an engineer, but I still don't like MATLAB. So I built this in C++, simple GUI application, and I just want to show it to you really quickly. So let's see if I can do this one-handed. over here. So we have here we have loaded these images. So here's the left image and the right image. And because these are basically perfect images, when you align them, here you see the alignment with the green line. So basically here the eye of the velociraptor on the same line will align with the eye on the left image of the same object. Because these images are already perfect, the aligned images are not different from the original images. Which means it will make the calculation easier. But let's just go on with this. We can calculate. So this is actually what the algorithm does. A disparity map, for example, from the left view. And this is very simple to the depth map that you've seen before, like the green car image. So here we see that the bright parts, like this head, are closer to the cameras, whereas the darker parts are further away. And from this, I can show you the 3D reconstructed point cloud right here. And you can see these shadows. So I'll show you this in a moment in another application. But just to show you, you can also, so this, here we have this open source algorithm, it's called Lifelike, which is a rather high quality algorithm, which was made for not real time. But if you, for example, take a really fast and bad algorithm, like this one, you can see that the result is also much worse. So for example, she is entirely missing her head, and the pet is also gone. It's very sad. And for example, so this shows that we have to find a balance between a high quality reconstruction and time to reconstruct. So you can see this is all live demo, so you can see this was instantly there basically. So let me show you like the better point cloud again in another application right here. So I can really zoom in and you can see this basically disappears. That's because it's a point cloud, so it has no dimension to it, it's just a point. So when you go too close, it basically disappears. So of course for a game you want to convert this to a different format, for example to a mesh of polygons, which I'll also show a bit later. But if I just make the point size here a bit bigger, you can see how it is. So you really have these shadows of for example on the wall. And you can see that it kind of falls apart when you turn too much. But as a first approach, it's rather convincing in 3D. So, and we're not missing a lot of pixels. So actually, like the complete floor is reconstructed, the complete walls, and there's no holes in like her body, for example, or in the dinosaur here. All right. Any questions so far? Yes. So the question is, how does a high resolution affect the algorithm, basically? How it would look. So basically here, when we go back to this, we take these original images and we align them. You see that this problem becomes actually much harder when you have high resolution pictures, because the alignment has to be much more precise, or the search window of pixels basically has to become bigger. Basically, we have to process more data. So this is a very good question, and we found that with our camera, our calibration was not good enough basically to get a very dense point cloud, which means that basically in the point cloud we had many holes. So that means that we need to improve the calibration now to get a better alignment and to get a better 3D output actually. If this kind of answers your questions. Okay, any other questions so far? Okay, great. Now what's next? I think I already said it. Yeah, calibration. So in the real world, when we go away from this virtual system, the cameras are not perfect. So here we see this image of the Eiffel Tower, which has great distortions. And basically, if you want to reconstruct like a straight line in 3D, but the image itself has a curve. Well, I mean, this is also a curve otherwise, but you know what I mean. And anyway, you cannot reconstruct from a curved image. So basically, what you do with calibration is you warp the image back so that straight lines are actually straight. And if you have this, you can go back to this very simple equation for the camera, which means that it's just a linear projection, which is also very fast to calculate, by the way. And how do we calibrate? Or we need a calibration target. And a simple one to start with is actually chessboards. So we need very good chessboards because we have very high resolution cameras. So we started with something like this, piece of paper. Of course, it's just to test the algorithm if it actually kind of works. And I can show you this right now. And then we also had, this was kind of a learning experience. So we had this bad chessboard here. We thought, okay, let's print it on a really stable piece of plastic. It's going to be great. But actually you see that here it's lying on the edge and it's curved. So that means that actually something that should be flat, and we assume it to be flat, is not flat, and it's not good, to put it simply. So what we did now is we had to get a really high precision aluminum, so metal chessboard, and have it really nicely printed, and from this we expect really good results. But also, of course, it's very heavy, so you can't just bring it to Paris on a day, you know. It's a different thing. Okay, so let me show the calibration software. I put just together a little script, and also made a little game out of it, so just to give you some visual feedback and to motivate you to actually it's less boring actually if it's a little like a game. So here I'm just using this internal here, the webcam of the laptop, and let me just start the script, and I hope this works. So here we can now launch this and make it a bit bigger. So you can see everything is in red. That means we have no data points there yet. And now when I hold here the chessboard, it should actually record the data. And then you can remove the red dots. And that's the goal. And basically, we want to cover the whole area of the sensor. So basically, we correct for the error in all areas of the camera, more or less. And you can see when I'm moving, it's not recording images. So this is something that I programmed. Basically, it detects the motion in the images, and it should only record when you hold still to minimize any like bad effects, like rolling shutter and so on. And from this, you should get like a well, now it's, I think I'm moving too much, or I don't know. And you can also see on the right here, basically what you should do is also you should like tilt the chessboard and move it closer and further away, and then, oh, I see, nice effect there. Yeah, anyway, and from this you can get the calibration like really basic one. So any questions on this right now? All right, good. You can also ask later if a question just pops in your mind, no problem. All right, now we found also that when I just hold this chessboard in my hand and I'm just shaking a little bit and my arm is not really precise, then it's still not good enough actually for our purposes. So we went and investigated for a robot arm, which can then actually hold the camera or hold the chessboard, like either is possible. And we went with the KUKA robotic arm, so this was actually cool stuff. So another someone from Nomoko, who works as a mechanical engineer, and we invited a couple of people from different robot companies, and we talked with them and said, yeah, this is what we done, this is what we want to do, and what do you have? And then we could also we visited 3 of them, and we found a really good deal from KUKA. And you can see that the one we got, for example, has plus minus 300 of a millimeter in precision when holding something of less than 6 kilograms. But that's already more precise than my arm is, so we're expecting pretty good results from this. So the first application will be the automatic calibration. You can see here some work in progress shots. So this is like a basic wood structure we built, some CAD for later on, like in the lab where we would like put different stuff, etc. And of course, it also has other applications. That's why we got it in the first place. So we can also use it, for example, for close range scanning of objects by kind of programming it to, like, it can look at the cup and see, oh, there's like a hole in the cup, so I should probably look inside of the hole, and kind of bring more intelligence to it, and also automation. Because if you want a really large database of 3D structures, you need to automate it at some point, because you cannot just hire more and more interns to do it for you, basically. All right. And then just a quick outlook, like what we tried already a little bit. So of course, if you take more pictures than just 2 with the stereo setup, you can get better results. So for example, here's a result from ETH scanning. It's not done by us, but it was done recently with a tablet computer. And I did some little tests with this. For example, here you can see. So what you see here is I was actually on a weekend. I went near Geneva to France in Ivoire. And I just took a video of a brick wall with a smartphone, so very basic camera that you all have access to. And what you can see here is a very basic 3D reconstruction of this. So basically here you can see the wall and points on the wall, which were matched between these images. So this is like the camera movement here. So me with the camera moving around. And here I moved a little bit closer to simulate basically the Nomoko camera, so to simulate what it means to have a higher pixel density on the surface. So if I get closer, it's like having a higher resolution from back here, if you know what I mean. So basically, if I have 4 megapixels here, it's the same as having 12 here, or something like this. I think it's a little bit erratic here, I'm not sure. Anyways, so I did this, and you can see that if I, for example, fix this with a good calibration, you can see that the path is much smoother, so you can see that it really helps the whole process. And this is also why we think that calibration right now is very important. So I want to show you very quickly the end result of this data set. So I just go back to this program here, make her disappear and make this one appear. And it's upside down. So let me rotate it. There it is. And basically what you kind of see is that, yeah, it's a wall, you can see that. It's not bad. And you can see these stones are kind of okay. I mean, you can see that they're stones, but they're not very good. So if you go too close, you can see that they look a bit crappy, actually. So but if you zoom in on the stone here in the middle, which I scanned more closely, because you were able to get more surface texture on it, this means that actually you can also reconstruct more of the 3D information. So hold on a second. I'm not sure why it's doing it. Let me just really quickly close it, because then we can look at it from a closer perspective. But anyways, you can see that it has more detail already, but let me just reopen it. Should be better. And you will see that it has plenty more detail. And you can also see that this is a mesh. So we went away from the point cloud and we converted it to a polygon object. This, no, I think it works. So this is, whoops. So this is just from a simple smartphone camera. You can really easily get a bunch of 3D models that you can use in a game or whatever. And of course, we want to improve upon that. Okay. Yes, and of course, in this case, we don't have the ground truth, like we don't know the precise measurements, but this was just also a visual test. Any questions so far? Just coming up, yeah. Exactly. Yeah, I actually tried to remember this, but it's good that you remind me. So if we look back here, well, let me make it bigger here. You can see that this is around 100 images, and I optimized it a little bit, so I threw away all the blurry images, and it was around, I think, in the end, 6 minutes to calculate this on a laptop. And I scaled it up a little bit to like 300 pictures, and it was a couple of hours on the laptop. So you see that this problem is really quadratic. But you can make a lot of smart optimizations. Like you can say, so we know that this view doesn't correlate with view in the other direction, for example. So you can decorrelate a lot of things to make it scale a little bit better. And we also hope to make it scale better with, for example, using GPUs and more cores, because this problem is easily parallelizable. Sorry? No, this is a simple software which is available online. It's just a little hard, like, to compile everything, but it's accessible to you. And this is not, we're not the first to do this. No. Maybe they took it into consideration, but somehow at some point they figured it wouldn't work, or I don't know. Yeah.
So we asked them as well, because I mean these stuff exists, right? So the problem kind of is that, I mean, you would have to scan the Cathedral of Notre Dame from a distance of 0.5 meter. So first point, difficult. I mean, you have someone climbing up and take. I mean, how do you do it in like? And if you have a drone coming 0.5 meter to the cathedral, and then it crashes into it and it destroys it, and it's like big mess, you know. So it's not practical from that standpoint. So you need really something which has the same pixel surface density when you are much further away. Yeah, so that's the first problem. Second problem is the results you normally get out of these are not very clean, so you have to clean them up manually. And because a lot of the artists that the gaming industry is working with are not used to this kind of workflow, it's faster to reconstruct it by hand than to optimize or to clean up the point cloud they get from the normal algorithms. So this is where a lot of work has to go in to clean up or make this cleanup process or get the first data so clean that you basically can filter the noise and can spare the cleanup process. So this is the important part, that in the end it goes completely automatic. That you have the input images and the output is a clean 3D model. That's it. Yeah, it has to get to this point, and that simply right now is not possible.
Yeah, I think it's also good that we can just put the last slide. So this is something else reconstructed. You can see that it's far from perfect. So that's why I put here 3D is not equal to 3D future work. So this is also a hint at possible, like, what people with jobs at Nomoko could do. So we're looking into high-res multi-view reconstruction, so really to how to make it work with a very high resolution, city mapping with drones. We spoke about this a lot. More about analyzing the individual images, for example, throwing out blurry images automatically. Then, of course, use the robot to scan the objects. And, of course, like we talked about this, removing the people from point clouds and so on, database, and then, of course, also like some AI, machine learning, whatever, deep learning stuff. So we already have a question round just now. So for any of this, just feel free to apply. You have the email address here. It's actually JBS, it's not jobs, it's jbs@nomoko.camera. Or you have his contact, just write, whatever, call, I don't know, send a postcard. Yeah, and of course, sorry, if everyone, like, if this is good, then this is also like just for the contacts. So Nielsen, which you met, and the other two, in case you want to take a picture of this. Otherwise, that's it. Any further questions so far? Yes? Sorry, in Zurich. Zurich, Switzerland. So it's like a little bit to the east in Switzerland, yeah.
3 hours with TGV.
Yeah, we just came here today, actually 4 hours with the train. Yeah, it's probably not doable every day, but like if you move there, it's not too far away. Right. Okay, thank you. So please just come up afterwards and talk to us. It's also fine. And otherwise, thank you for your attention. It was quite a long talk, so thank you.